Okay, in this example, we're going to find the area of an equilateral triangle. Now, the area of a triangle we know is going to be the area is equal to the base times the height divided by 2. And that's a basic formula that we all should have already learned. An equilateral triangle is a special triangle, and there are certain things that we can do with it. Now, based on the information that's given, they give us this part right here, 14 inches. This part right here is what they call the radius. And the radius, the reason why it's called a radius is because if I made a perfect circle all the way around this, that would be the radius of that circle. So we're going to have to find the base, and we're going to have to find the height of this little triangle. Now, the way we're going to do that is we're going to use what we've learned about the special right triangles. We learned about the 30, 60, 90 and the 45, 45, 90. And based on that information, we're going to find the area of that small triangle. In order to determine which one we're going to use, though, we first must find the central angle. To find the central angle, if I went all the way around this part right here, if I went all the way around, that would be 360 degrees. And then we're going to take that and we're going to divide it by the number of triangles. And we're going to get to that in a second here. And I just want to write here on the side that T is going to equal the number of triangles. Let me just put triangles. Okay, so now I'm going to talk about the triangles. If I take this and I extend it out right here, and I extend out my dotted line here, extend out my dotted line here, and then do this guy right here, what we're going to see is I got 1, 2, 3, 4, 5, 6 congruent triangles. And that 6 is what we're going to use to find that central angle. So I'm going to take that 360 divided by 6, and I'll get 60 degrees. So my second step will be that 60 degrees means that we're going to use the 30, 60, 90 special right triangle. So it's either going to be, let me go ahead and fix this real quick. Boom. 60 degrees. And that means a 30, 60, 90, which means on my next step, what I'm going to do is I'm going to use the radius that's given to find the other legs. So my third step is going to be to find the legs, and I'm going to do that by using my 30, 60, 90 tic-tac-toe. That's x square root of 3, and then 2x. If I look at this guy right here, that 14 is straight across from the 90. So this guy goes right here. So I'll put my 14 right here. This is what I'm going to solve. So I take my 2x equals 14, divide both sides by 2, x is equal to 7. My 7 will go right to here. Plug in 7 for x here, and I get this. This guy is going to be my height. My base is going to be that. So then on my next step, I'm going to find the area of that small triangle. So on my step 4, I'm going to use my area equals base times height divided by 2, which in this case is going to be 7 times 7 square root of 3 divided by 2. And that will be 49 square root of 3 divided by 2. And I will add my units, which is inches squared. Whenever you do area, it's going to be a square of those units. If you don't have a unit, you'll put U in units. So once I find the area of the small triangle, I'm going to multiply it by the total number of triangles and get the entire area. So my fifth step fifth step will be total number, which is 6, times that area, which is 49, over 2, square root of 3. If you put this into your calculator, you will get a decimal, but we're doing exact, so we're gonna get a radical in it. So when I do this, I do 2, that goes into that 3, so I do 3 times 9 is 27, carry the 2, that's 12, that's my 14, bring my square root of 3, and it will be inches squared. So that's the area of the equation.